Good day, everyone. We are working out January 2022 CSEC Mathematics Paper 2, number 5. We have our OGIV here, cumulative frequency diagram. Shows information about the distance that each of 120 students walks to school on a particular day. So how many students walk at most 1 kilometer to school on that day? All right, you just read your information from the graph. So this is 1 kilometer here. So I carry a straight line up and a straight line horizontally. And I read off the value. All right, so the scale on the y-axis, we are going, this is 20 divided by 10, we are going up. 40 take away 20 is 20 divided by 10 small squares, which is 10. Sorry, which is 2. 10 into 20 is 2. So the middle value, the midway halfway point is 30, 32, 34, 36. So this is 36. All right, so how many students walk at most, which represents less than or equal to 1. All right, less than or equal to 1. So that's 36 students. Okay. Okay, let us get the median. So the median is called Q2. All right, the second quarter, which is 50% of 120. It happens at 50% of 120, which is the cumulative frequency. So 50% of 120 is 1/2. So 1/2 of 120 is 60. So we are going to read off this information from our graph again. And from 60, we go across with a straight line until we reach the graph. And we come down the vertical line to the y-axis and we read off our value. All right, whatever that is, we read it off. So if you take 1.5 minus 1, you get 0.5. Divided by 10, you get 0.05. So midway between 1.5 and 1, we have 1.25. So 1.25 plus 0.05 is 1.3. Okay, so this is 1.3. And this is 1.3 kilometers. Okay, that's the median. The lower quarter is called Q1, just 25% of the cumulative frequency. It occurs at 25% of the cumulative frequency. So 1/4 of 120 is 30. So what you will do is we'll look for 30, 30. And we're going to draw a line from 30 going across until we meet the graph. And then we come down with a straight vertical line till we meet the y-axis. And then we read off our answer from there. Okay, so we have, all right, you have 0.0, this would be 0.9 because we take away, we say 1 take away 0.1, and we got 0.9. Remember, each small square is 0.05. Okay, so we get 0.9 for the lower quartile. The interquartile range now is Q3 minus Q1. And Q3 is equal to 75% of the 120, which is 3/4 of 120. Which is 90, all right? So we are going to look at 90 on our graph. 90, and we're going to draw a line going across till we reach the graph, and then we're going to draw a line going vertically upward. All right, to meet that point as shown. Okay, and then we read off our value. So this will be 1.55 because we are going up Now this is 1.55 since we are going up in 0.05 at a time on the x-axis. So we have 1.55 as Q3, subtract 0.9. Okay, so with our calculators, we subtract that 0.65 kilometers. Okay, so a student is chosen at random. What's the probability that the student walked for more than 1.5 kilometers to school that day? So let's read off the 1.5 from the graph. 1.5 kilometers. All right, so 1.5 kilometers, and we're gonna read it off. All right, and let's try our best to find out exactly where this line from 1.5 going up will cut. It'll touch the graph, right? So it seems to touch at this point. And we just carry a horizontal line across, and that gives us 82. So we have 82 here. So this 82 represents 82 students. All right, so 82 students will travel at most 1.5 kilometers, which is less than or equal to 1.5. But they ask for more than, what's more than 1.5 kilometers. So we have to say the total number of students, 120 minus the 82, divided by the total amount of students. And that will give our probability. So 38 divided by 120, we can simplify this. 2 into 38 is 19, 2 into 20 is 60. 19 over 60 is the answer. It can also be written as a decimal to 2 places. 0.32 is the probability. Okay. Complete the table below and use the information to calculate an estimate of the mean distance walked by students on that day. So from 1.5 to 2, we find the average, 1.5 plus 2 divided by 2, right? 1.5 plus 2 divided by 2, 3.5 divided by 2, 1.75. So we get 1.75. All right, the number of students. Now, we have to find out how many students at 1.5, and we got 82. We got 82 before. How many students at the position of walk up to 2 kilometers? So let's just go back to the graph. So 2 kilometers, let's follow this black line going up. Let's draw a line going across and estimating it's up. Okay, it's about around here. All right, it's closer to here, right? And we just read off the value, which is 110 plus 2, 112. All right, so it seems to be closer to 112, so let's call it 112. Let's approximate it to 112. All right, so now we have 112 minus 82, which is 30. So we have 30 here. And f times x is 1.75. This is 1.75 times 30, all right? 1.75 times 30 is 52.5. All right, let's look at the other one, the number of students from 2 to 2.5. So at 2, we got 112. Let's look at 2.5. So 2.5 going up, following this black line. And then we draw a line going across. All right. And this is 118, right? Okay, it is 2 less than 120. So 118, take away 112. All right, it's just 118 today. 112 and we get 6. All right, and then we multiply 2.25 times 6 to get our answer in this cell here. All right, so 2.25 times 6, we get 13.5. So at this point in time, we'd like to add up all the numbers in this column. 3 plus 18 plus 57.5 and so on. We add them up. 0.5 plus 13.5 plus 5.5, 150. Let's add up this column. 12 plus 24 plus 46 and so on. 12 plus 24 plus 46 plus 30 plus 6 plus 2, 120. We are asked to calculate the mean distance walked by the students. All right, so the mean distance walked by the students, all right, is equal to, all right, we can call it the sum of XF divided by the sum of F, right, which should be 150 divided by 120, okay? So 150 divided by 120, 1.25 kilometers, all right? That's the answer. All right. Okay, so this column is really the sum of F, and this one is the sum of XF. All right. Sum of the frequencies and the sum of the product of midpoint times frequency XF, right? Around 50. Right, and that's the end of the question. Thanks for watching. Do have a wonderful day.